Hi, all. Myself, Narender, working as an assistant professor in BSH Mathematics in B.V. Raju Institute of Technology. Now I am dealing the course with the linear algebra and calculus. In this part, I am dealing with the unit 5, the content with this finding the particular integral for the non-homogeneous terms. So that we call as the special cases. Already in the last module, we finished the case 1, that is f of d of y equal to q of x, where the q of x equal to e power x. Now we'll deal with this second case, the case 2. The case 2 is second model. This is in the special case. The special case is 2 is what we call the special case 2 is if f of d of y equal to q of x, where this q of x will be equal to sin ax or cos ax. This is sin ax or cos ax. So again we have the two cases. In this case we'll discuss one by one. Now case A, the case A will be, here the case A is that the particular integral, we are finding the particular integral case only, the q of x. Now let us write 1 by f of d of sin ax, or I'll write at a time, but in the realistic problem we'll get only one case, that is cos or sin. Now put d square equal to minus a square, then the particular integral will be 1 by f of minus a square of cos ax or sin ax. Here f of minus a square is not equal to 0. I think you people have a doubt on this. When I substitute the d square equal to minus a square, what is the output actually? We'll discuss one short example. The short example I'll write here, d square plus 2d plus 1 of y equal to sin 2x. Let us consider the equation. What I mentioned, 1 by f of d sin x, then put d square equal to minus a square. I'll write 1 by f of d means that d square plus 2d plus 1 of sin 2x. Then here the sin ax means a equal to 2 here. Then a equal to 2, then we'll get d square equal to minus a square, that is a minus 4. When I substitute in this equation minus 4 plus, in place of d we cannot write root over something. So d square equal to minus a square means d equal to minus a root over minus a square. This is not correct. So don't follow this one. If I follow this, we'll get the imaginary parts. Again, it is complicated. Now, no need to write the things. You can keep this 2d plus 1 like this of sin 2x. Now, this I can write as that 2d minus 3 sin 2x. Now, after this, what we have to do? Then we have to rationalize this. The rationalized case 1 by 2d minus 3 into, we'll go for the rationalized 2d plus 3 sin 2x. D is called that d by dx, that is already we know this. If d is called the d by dx, then we can, the rationalized 2d square, this is 4d square minus 9, that is 4d square minus 9 means again we'll put the d square equal to minus 4, then it is not equal to 0. Now this is the procedure when we follow this equal to. Now when it is equal to, not equal to 0. But if it is equal to 0, what is the output? Now we'll see, that is a case 2. We'll write the case 2 here. The case 2 is, whether it is sin or cos, the same procedure we have to follow. If the case 2 is a 0, now what if it is a 0, we'll see how we are going to solve this, the special case. Now the special case will be if f of minus a square is equal to 0. Now what happened? If f of minus a square is a 0, that means we'll put the d square equal to minus a square equal to 0. Now this is 1 by f of d cos ax will be equal to directly x by 2a of sin ax. That is the final answer. Now 1 by f of d of sin ax will be minus x by 2a of cos ax. So when it is possible, I will write this is the case in similar way. This is d square plus a square, then cos ax. That is the d square plus a square only, that f of minus a square becomes 0 directly. The same way, when it is in d square plus a square, then sine ax. So the possibility of getting this one, this f of d contains only that even power of derivatives. Even power of derivatives means d square, d power 4, d power 6, it is a possibility. Then we'll get this f of d become 0. Now this is the one example for this. When it is 0, this f of minus a square will be 0. That means put d square equal to minus a square. Now this is a 0 now. 1 by 0 it is not valid. Therefore, the final answer of this one will be, this is the final answer of this one. So that is the case. This is the case 2, the special case. Now we'll solve for the 2 problems on these 2 cases. So now we'll discuss the next problem. Now the first problem. Solve d square plus 9 of y equal to cos 3x. So this is the d square plus 9 of y equal to cos 3x. Let us see, this is a d square plus a square, this is a 3 square I can write. So here you can understand, we'll get the second case. So easily you can understand where we get the second case. That is the formation of the form of the f of d will be in terms of events. So that is a d square plus 9, that is d square plus 3 square. Now this is 0 ultimately. Now we'll write the solution. Given d square plus 9 of y equal to cos 3x. This is the equation 1. Now auxiliary equation, we have to find out the auxiliary equation first of all. F of m equal to 0, that is f of m equal to m square plus 9 equal to 0, that is m equal to plus or minus 3i. M equal to plus or minus 3i, therefore the complementary function will be c1 cos 3x plus c2 sin 3x. Now this is a solution for this complementary function. Now we'll write the particular integral. The particular integral is 1 by f of d of cos 3x, then a equal to 3 here. That is 1 by d square plus 9, then cos 3x. Here I am writing the hint for you. Here if d square equal to minus a square, that is equal to minus 9, then f of minus a square will be equal to 0. That f of minus a square equal to 0. If f of minus a square equal to 0, we have a formula. That is the formula I'll write here. 1 by f of d of cos ax equal to x by 2a of sin ax. When it is the possible, f of minus a square is equal to 0. Now in such cases, it is satisfied this case. Therefore, that is cos ax means cos 3x, that is x by 2a, that is 2 into 3 sin 3x. Now this is x by 6 of sin 3x is a particular integral. Therefore, the general solution will be cf plus pi equal to c1 cos 3x plus c2 sin 3x plus x into sin 3x by 6 is the final solution. Now see, this problem also you can solve by the very first method, that is the inverse operator case. Now see how much easily we are evaluating the problems with the special cases. So that's why we have to learn the special cases. Whenever it is in the product case, the previous one is in e power x and the cos ax. The product case will be also we can solve easily by using the special cases. Now we'll solve another model problem for this case. So whether if it is not equal to 0, how we can solve these problems. Now the second problem, d square plus 3d plus 2 of y equal to sin 3x. So this is the first case you can easily identify because the odd derivatives will be available. Whenever the equation containing the odd derivatives, it becomes the first case. So we'll write the solution. given equation d square plus 3d plus 2 of y equal to sine 3x. So here the given differential equation is given like this. Then we'll find out the as it is that auxiliary equation. This is the common method, common procedure for all the problems of the fifth unit. F of m equal to d square plus 3d, sorry, we'll write in terms of m, that is m square plus 3m plus 2 equal to 0. Now that is, this is I can write m plus 1 into m minus m plus 2 equal to 0. That is 2 into 1, that is 2 plus 1 is the factorization method. Now that is m equal to minus 1 comma minus 2 are the roots. Then the complementary function will be c1 e power minus x plus c2 e power minus 2x. Now this is the complementary function. Now we'll write the particular integral. Then how we are going to find out the particular integral for the not equal to 0 case? 1 by f of d. This is a procedure you have to follow. Whenever we are not finding the particular integral, don't write the sine 3x by f of d. So this is the format of writing the particular integral, 1 by f of d of sine 3x. Now that is d square plus 3d plus 2 of sine 3x. Now we'll put d square equal to minus a square, that is equal to minus 9. Therefore, the particular integral will become 1 by minus 9 plus 3d plus 2 of sine 3x. Now what I get here? Now this I get like 3d minus 9 plus 2, that is minus 7. Now sine 3x. Here you can observe one point. The students always will struck up this step, because after this what we have to do. So we not remember the rationalized concept. If we are not remember the rationalized concept, the problem will stop here. So it's not continue. So therefore, please focus on these steps. Now we'll rationalize this 3d minus 7 into 3d plus 7 into sine 3x. Now we'll rationalize this. This will become 3d plus 7 of, this is 9d square minus 49 into sine 3x. So first we'll finish this term. We'll write this 1 by 9d square minus 49 into 3d of sine 3x. So d means I call, what is the d means is that d by dx. Now I'll write here d is equal to d by dx. For your reference I'm writing here, plus 7 into sine 3x. Now 1 by 9d square minus 49. This d by dx is the derivative of sine x, will be the cos x. So cos 3x, that is 3 into 3, that is 9 cos 3x plus 7 sine 3x. Now I'll split this for solving the next procedure. 9d square minus 49 of 9 cos 3x plus 1 by 9d square minus 49 of 7 sine 3x. After this, again we have to follow the procedure. What we are following in the initial stage, we have to follow the same procedure. That is, put d square equal to minus a square equal to minus 9. That is, we'll write 1 by 9d square is 9 minus 81 minus 41 into 9 cos 3x minus 81 minus 49 into 7 sine 3x. Now this is 130 and this is also 130. I'll take the minus 130. 1 by 130 is a common. That is 9 cos 3x plus 7 sine 3x. Now this is a particular integral. Now we'll write the general solution. The general solution, again the combination of complementary function and particular integral. Now therefore the general solution will be equal to CF plus PI. So that is equal to C1 e power minus x plus C2 e power minus 2x plus minus 1 by 130 or times of 9 cos 3x plus 7 sin 3x. This is the case when we get not equal to 0. But equal to 0 case is very simple. Direct formulas are available for that equal to 0. F of minus a square equal to 0. But f of minus a square is not equal to 0. We have to follow this. See, this step is a very crucial step. This is the step. If you are not able to rationalize this, we cannot complete the problem properly. So focus on this step, and I'll give some models for practice. So please practice these problems to understand the problems on this method. Now d square minus 3d plus 2 of y equal to cos 3x. Second model, d square plus 4 of y equal to e power x plus sin 2x plus cos 2x. So the previous model also will come, because we already finished the previous model, that is a q of x equal to x power m. Q of x equal to e power x. D square minus 4d plus 3 of y equal to sin 3x into cos 2x. Here you have to follow this. We don't have a problem direct method for the sin a into sin b or sin a into cos b. So here we have a formula, sin a sin b is we can write sin a plus b and sin a minus b. Then you can follow this for this case. The fourth model also same, like d square plus 1 of y equal to sin x into sin 2x. Now these are the four models, and see, whenever the equation is containing with that odd derivatives, this is d by dx, then it is not equal to 0. That whatever the problems, the previous problem what we are solving, the previous problem will get this case. Whenever that even power, so only even power d square like d power 4, this is the problem for the very good example to solve the second case, that is equal to 0. So we have a problems here. So the questions I'll round up for this case and the second case. So these are the problems you can solve by the first model, and the next two 1 and 3 questions you can solve by the second model. So you can follow the procedure of the first and second models. You can solve these 4 questions. Now this is a case 2. Till now we are discussing the case 1 and case 2. The special case is 2 cases. One is that q of x will be e power x, and one is that q of x will be sin ax and cos ax. Now the next module will finish the third case. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.